All right, for this bell work, we're just going to simplify this expression. Remember, when it says simplify the expression, it's really telling you to combine the like terms. Okay? So I'm going to look for any like terms to combine. So I got some x's first. That's the first thing I'm going to focus on is the 7x's. Then I got these negative 2x's, and then it may be good to see that as a negative 1x, showing the phantom 1 value right there. Okay, so that's a negative 1x. How many x's will this result in? Well, you had the 7 to start out with, the negative 2, and the negative 1. This comes out reading, though, as 7 minus 2 minus 1. So 7 minus 2 minus 1, that's something that I just go straight to my calculator and plug in. And when I do, I get 4. That tells me how many x's I have, 4 x's. Now I'll combine my constants, because I got 36 and 4, which when I combine those, they're both positive. So it's 36 plus 4, which is 40. Now the 40 is positive, so I need to show the plus sign with it, okay? The plus sign indicates that that term 40 is in fact positive. Of course, if you rewrote it in a different order, it's okay as long as the terms have the same sign. So the 40 is positive, and then the 4x is positive with now a plus sign. This is exactly the same thing, just shown in a different way. That's it. All right, there's our objective. I can use the distributive property in combining like terms to simplify expressions. Now we've already seen combining like terms just like we did on the bell work, but the distributive property is a little bit new for us, so we'll take a look at that too. All right, the distributive property, just so you understand, in the order of operations, pretty much the distributive property lines up with multiplication, okay? So if you ever see the distributive property, it is telling you to multiply. Okay? Well, how can we tell it's multiplication? Because between the a and the parentheses here, there's no operation being shown, which means it has to be multiplication. It's the only operation that doesn't always have to be shown. And we can see between the a and the b and the a and the c right there as well. Okay? Now, this is just a general rule for it. Most of the time, it's shown with what is called distributive rainbows like this. So this means we're multiplying whatever's on the outside of the parentheses by whatever's, all the terms, I should say, on the inside of the parentheses. That's why you're seeing here a times b, so that's from this rainbow. And then from a and c, you multiply those two as well. And yes, it's okay if there's subtraction between, but remember, we treat those terms as though they are negative terms if you see subtraction. Now, it's possible from time to time to have just one distribution. So it can look something like this, and then it's just one single distribution in there. Well, that's just the same as taking a and multiplying it by b. It's also okay to have more than two terms at a time as well. So we can show many terms in there, maybe b, c, and d, like this, okay? Well, then you're distributing the a to all three values on this, which again, distributing means we're multiplying. So keep in mind that this is a very abstract way to look at it. It means that a's, b's, and c's could look like anything. Like the b, maybe that's a 2x. Maybe the c is a positive 5 right there, right? Or maybe even the e is a negative 3x. That could happen too. Okay, you could see fractions as well. Maybe it's like a negative 3/4 x, like this. Then you can distribute fractions into parentheses too. Now the order of this is always to distribute and then to combine like terms, because by the order of operations, you have to do multiplication before you do any addition or subtraction. So, like we saw in the bell work, where there was addition and subtraction of terms, that's combining like terms. You must do distribution first because it is considered multiplication. Something else about distribution I should have mentioned on this slide is, so we see here that we got like a, this is the general form for it, a times b plus c, like this, okay? And then you distribute the a into the parentheses this way. It's possible from time to time you'll see that you have to distribute from the right side as well, but it's still distribution because it's multiplication by a, okay? So you distribute just kind of the opposite direction, that's all. But remember, as long as you understand that distribution is multiplication, then you'll understand that it doesn't matter which side that a is on, because it's on the outside of the parentheses, and it's not showing an operation, which means it has to be multiplication. So here we go. This is a 6 that's being distributed into this 8x. Now, don't make the mistake of distributing the 6 into the 8 and the x, because it's only one term right here that you need to distribute the 6 into. Now, if there was a plus sign between the 8 and the x, that would be fine, but there is not, so don't. This is like saying you got 6 groups of 8. And remember, the distribution right there indicates that we are looking at distribution, which is multiplication, okay? So, this will tell us, when I take this 6 and multiply it by 8 x's, this will in the end tell me how many x's I have. So to figure that out, all I got to do is 6 times 8, which is, that's how many x's I got, 48 right here. So my final answer is 48x. And that's how I would type it into Canvas to get full credit right here. All right, how about this one? Well, this is distribution because it's not showing that sign. If it helps you to see that operation right there, then do it. 15 times the quantity a minus 3. So right here, I would distribute the 15 into the a. I'm going to show that as 1a. So I can see that coefficient right there. We talked extensively about phantom 1s last time, and for some students, it's beneficial to see that phantom 1. So really, with this distribution, I'm taking 15 and multiplying it by 1a. How many a's will this result in? Well, 15 times 1 is 15. I have 15 a's from that multiplication. But then I also have the 15 multiplied by, and again, this is not just 3. Because it's minus 3, I have to show it as negative 3 right here. Now that's something, just like you could have done 15 times 1 in the calculator, you can do 15 times negative 3 in the calculator, and it will show you negative 45. Now, are there any letters associated with this 45? Nope, there's not. And since it's negative, I just show the negative as a minus sign because remember, a term that's negative, we can show that with a minus sign to make it simplified, okay? 15 a's minus 45. And this, by the way, is all I would type in to Canvas. Although it is acceptable, remember, we talked about this on the bell work. If you switch these around, as long as the terms keep the signs, you could have written this as negative 45 and a positive, so plus 15a like this. Although for me, I would just keep this in order because I kept the first a term on the left and then the constant here on the right after multiplication. Now this goes back to the last lesson, which we talked about. Some students were putting in something like this, 15a plus negative 45, which is, it's correct. Like it's, that is considered the same thing as what we have right here, but it's not considered fully simplified because of the operation and the negative. Just, again, make that, instead of plus a negative, just make it a negative 45. So 15a minus 45. And again, this is exactly how you type this into the Canvas. All right, so like I was saying on the couple slides ago here, it's possible to be distributing from the right. And so for me, I always distribute first to the term furthest to the left. And yes, that is 1x, by the way. So that means I would take my 14 and I'd have 14 groups of 1x's. This would result in 14 x's from that multiplication. Okay, so I got 14 x's, and then I can distribute this 14 into this negative 2y. Remember, it's a negative because of the minus sign, okay? So how many y's would that result in? 14 times negative 2. Just punch that into the calculator, and then it will tell you how many y's you have. Negative 28 y's. Now be careful not to combine these because they are not like terms. You got x term and a y term. Those are not the same. It's like 14 apples and 28 oranges. That doesn't give you, I guess that'd be 42 apples or oranges. I mean 42 pieces of fruit, but they're not the same, okay? So this is how we want to keep this answer right here in it's a simplified form of that expression. All right, here's a good one. Now this one has 3 different distributions on it, but it's still doable. Notice on the inside of that set of parentheses, they are not like terms, so don't even look to combine those, okay? Keep them separated because they're not considered like terms. So that's what we'll do, okay? So I'm going to go to distribute these. And by distribution, remember, distribution means multiplication. So that would be first negative 6 groups of 3x's, which would result in negative 18x's. But also negative 6 groups of negative 7. Now when I multiply these, I get positive 42 on the calculator. But since it's positive, I do need to show that plus sign there to indicate that it is actually positive. And then I'll distribute this negative 6 into this 4z. So that's negative 6 groups of 4z's. Well, how many z's would that be? Well, negative 6 times 4 would be negative 24 z's. Okay? And that right there actually is about as simplified as we can make this expression here. Okay? Now, when you put these answers into Canvas, just use lowercase letters. If you type in uppercase letters, it's not going to accept those. So just lowercases. So let's look at a different type of problem on this. Okay. So even like a 3/4, it is possible to distribute this into a set of parentheses. So I'm just kind of making this up as I go. Let's make this like 16x minus 20. Okay. You guys try this one, and I know there's a fraction to distribute here, but it's doable, especially if you use your calculator, okay? Take a minute and try this one out, then we'll go over it. All right, for this one, we are distributing 3/4 into this set of parentheses. So, remember, distribution is multiplication, so that's really 3/4 times 16x's. Now, how many x's is that? I just go to my calculator, I type in 3/4, and then multiply that by 16. When I push enter, it shows me 12 x's right there, okay? And then I'll distribute my 3/4, so that's multiply 3/4 by here, that's negative 20. So 3/4, and then I'm gonna multiply this by negative 20, enter, and it gives me a negative 15 right there, okay? And again, this would be my final answer. If by chance you have some kind of fraction on assignment. So let's say that this was my answer, right? So like negative 2/3 x plus 4/5, something like this, okay? If you need to type something like that into the homework, which you will, I would put this in as negative 2/3 like this, and then I'd multiply it by x. And then I would add 4/5. This one won't matter. So I would just keep it like this, okay? Now, it would be okay if you didn't put the parentheses on Canvas, but I would recommend doing it just so we know that the negative 2/3 is together on there. Canvas is kind of crappy that way, but we do what we can. So since the bell work, or the objective rather, it showed that we not only have to distribute, but we also have to be able to combine like terms at the same time. We're gonna do it like this, okay? And then even, I don't know, this one. Now this one's a little bit bigger, but it's still doable as long as you understand to distribute first, okay? So take a minute and try this one out, then we'll go over this one as well. All right, for this problem right here is, we're not just distributing this 4, okay? It's actually a negative 4 that we're distributing because of the minus. That makes it a negative 4 value. Now another common mistake we see from students on this one is to combine 7 minus 4 right here. But remember, distribution is multiplication, so that's out of order of the operations, okay? You have to do this distribution before you look to start adding and subtracting. So don't do 7 minus 4 there first. And if you made that mistake right now, that's okay. We're just practicing, but hopefully you can learn that now so you don't do it in the future. So you'll see also that this negative 4 is not being distributed to this 9x because distribution is multiplication. This 9x is being added to this term. So you don't distribute the negative 4 to the 9x either, which is another common mistake. So I will distribute. So negative 4 times 3x's, that would result in negative 12x's. And then I also have negative 4 times 5, negative 4 groups of 5, which is negative 20 there. The other values, since we didn't do anything with them, they just kind of drop. Okay, so we got 7 minus 12x minus 20, and you still have the plus 9x there. Okay, so Now that we have it like this, it's pretty much the same type of problem that we saw on the bell work. We're just looking to combine like terms. So I would combine my 7 and negative 20, which would be negative 13 there. And also, I can combine my x's. Negative 12x's and negative 9x's would result, that's positive 9x's. That would result in negative 3x's. And of course, you could write this in a different order with the negative 3x as the first term, and then the negative 13 as the second term. Both of these will work, but again, you have to do this distribution first and then look to combine like terms. There's another type of problem that you'll see on the assignment. So it says, Abby bought 6 books for $B each and a DVD for 25 bucks. We'll look at these expressions, but first off, I just want to acknowledge here that if we look at, I guess, the cost for the books. So what's happening with Abby? Well, it says here that she's going to purchase 6 books, right? So I'm going to take 6 books. And how much does each book cost? Because that's what I would multiply the 6 by, 6 groups of this many dollars. We just don't know how many dollars it is. So even though it kind of looks like a 6, it's a B. 6 times B, okay? But then in addition to that, Abby's also going to purchase the DVD, which it tells us up here is 25 bucks. So we just need something to match that. And as an expression, just offhand, that means you'd take the cost of the books, 6 times B, and to figure out the cost, you would add the cost of the DVD, which is 25. So we just need stuff that is the same as this, which is being shown actually directly right here. So I know C will work, but what about these other ones? Well, A is showing 6 plus B, where we actually need 6 times B because there's 6 books for $B. This is communicating that they're 2 different items. Okay, so A, garbage. B, now this is like saying, on this one, this is the same as saying you got 6 groups of B and 25. Okay, but that's not really what we want right here, okay? Oh, okay. And you could see this if you distributed, right? 6 times B would be 6B, and then 6 times 25 would be positive 125. This is not the same as the 6B plus 25. It's 125. So B, as it turns out, garbage. Don't worry about B. What about D? Well, this is like saying that there's 25 of the books instead of 6 of them. So D, yep, that's not going to work either. Garbage. Now, E's written a little different. If you look at the cost of the books, that's 6 groups of B, and 6 groups of B indicates that you would have 6 Bs. So 1, 2, 3, 4, 5, and 6. Remember as well that this multiplication here is just a simplified form of addition. So that means that between these, you could show some addition, okay? Enough addition, okay? So it's like adding all those B's together. And that's what we have right here, 6 B's added together, and then you still have the plus 25. So as it turns out, this E right here it's a good expression to represent what we had originally, 6 books for $B and a DVD for 25 bucks. Well, there's our objective. We did see a lot of distribution in this distributive property. But we also looked at a combination of distribution and then also combining like terms to simplify our expressions. Because remember, in the end, when it says to simplify expressions, it's talking about combining like terms. Now, that also applies to fractions. If you can ever simplify your fractions, then do. But we know that the calculators will do that for us if you just punch it in.